Hi guys, it's Mrs. Chalk here. I decided to do your very last lesson. This is your last lesson for this unit in an ed puzzle so that I can get caught up on grading and things like that. So open your binders and take notes. Okay, Diego's vegetable garden currently measures a 10 by 10. Diego wants to change the size of his garden and will either use a scale factor of 2 or a half. Let's complete the table and see what happens. And we're going to try to derive the rules from this. Okay, so the perimeter, let's use green. The perimeter, that's when you add all the sides, would be 40. And then the area is the base times the height, so that would be 100. Now, let's do a scale factor of 2. So that would make this a 20 by 20, 20, and a 20. So if we add that together, we're going to have 80. And then if we do the area, 20 times 20 is 400. Okay, what about if we halved it? What if we did a 5 by 5? That's our scale factor. We halved the measurements. So our area is 5 times 5, so it's 25. And our perimeter is 5, 10, 15, 20. Okay? So something interesting to know is, like if we did a scale factor of 2, or a half, it looks like the perimeter does the same thing. However, the area does not. Look at the area. We didn't just do the area times 2, or we didn't take the area in half. Okay? And that's because area is squared. Area is, like if I would have put this right, I would have said feet squared. Feet squared. Okay, so we're going to talk more about that. Dilations effect on area and perimeter. When a figure is dilated by a scale factor of x, its perimeter will change by a factor of x. But its area will change by a factor of x squared. For example, if a figure is dilated by a scale factor of 10, its perimeter will change by a factor of 10, okay? But its area will change by a factor of 10 squared, or 100, okay? So think about this for a second. If Diego decided to use a scale factor of 3, how would the perimeter and the area of the new garden compare to the perimeter and the area, to the current perimeter and area? Answer that question. Okay, did you get it right? Let's move on. That's basically all the notes. Now we're just going to practice what we learned, okay? So, a figure will be dilated by a scale factor of 9. By what factor will the perimeter and the area of the figure change? So, the perimeter will change by a factor. Factor means multiplying, right? Factor of 9. But the area will change by a factor of 9 squared, which would be 81. So you'd have to multiply by 81. That's crazy. Now what about when it's a fraction? Don't freak out. You just do it to the top and do it to the bottom. Okay? So the perimeter would change by 4/5. Okay? But the area would change by, do it to the top and the bottom, by 16/25. So we're going to do the 4 squared and the 5 squared. Okay? Okay, I'm going to let you answer number 3. So a figure has a perimeter of 15 What will the new perimeter be after a dilation scale of 4? And now I want you to answer number 4. What will the new perimeter be? Now we're just talking perimeter. Perimeter be with that scale factor. Okay, what about answering number 5? And then answer number 6. Did you get them right? If not, don't worry, you get 2 chances to do this, okay? So you can do it again, you can learn it better, come and talk to me, and we can do it again. Okay, let's look at this one. Kira ordered a rectangle print of 2 recent photos from a family trip. The prints are similar figures, and each has a dimension of the larger print and each dimension of the larger print is 1.2 times the corresponding dimensions of the smaller. How does the perimeter of the larger compare to the smaller? Well, the perimeter, as we know, is going to be 1.2 times larger. Okay? But how does the area compare? Well, the area is going to be 1.44 because it's 1.2 squared. So it's 1.44 times larger than the smaller one. Okay, let's have you do number 8 on your own. You're just putting if it's true or false. When you are done, you have the independent practice to do. Thank you.